Today we're going to take a look at tangent lines to a circle. So today's topic is tangent lines to a circle. So let's go over a few things. Of course, as always, pause the video as needed to take your notes. So a tangent to a circle is a line in the plane of the circle that intersects the circle in exactly one point. The point where a circle and a tangent intersect is called the point of tangency. Ray BA is a tangent ray, and BA is a tangent segment. So I got a picture down here. Lots of times it's good to look at a picture, a little visual of what's going on. So tangent to a circle is a line in the plane of the circle that intersects the circle in exactly one point. So I have this line here, AB, that is intersecting this circle. So not the best circle, but here we go. So I have this circle here, and I have a line that is intersecting the circle. Point B is called the point of tangency. That is the point where the line intersects the circle. So that's called the point of tangency. BA is a ray, and BA, just this part here, is the line segment. And if from B all the way on to forever with the arrow at the top, that's my ray. Take home point for this little section is that I have a line that is going to intersect the circle in only one spot. That spot is called the point of tangency. Other things that I know about that one spot: if a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. So if I have a line that intersects the circle, then I can draw a radius like I've done down here. I drew radius OPN, that's my radius. Then it is perpendicular to the radius. So in this picture here, we can say that AB is perpendicular to OP. And perpendicular, makes the right angle and things like that. So I drew in the right angle here. So let me zoom in just a little bit before we jump into some problems. So again, if a line is tangent to the circle, so line AB is tangent to the circle at point P. Point P is where it intersects itself. Then we know that they are perpendicular and it makes a 90-degree angle. So AB and OP, which is the radius, they form a 90-degree angle. They are perpendicular to one another. So I got some examples that we're going to go through. We'll go nice and slow, baby steps, and working our way through. And so this is all about knowing what is perpendicular to the circle, and we should be able to find missing angle values. So number one, ML and MN are tangent to circle O. So this is circle O. So we need to write that out. That is circle O. Okay. We want to find the value of X. Okay. So I got ML. That's a point of tangency L. And MN is a point of tangency. So since I have 2 points of tangency, I know that they form a right angle. So it's tangent at point L. I know that this forms a right angle. Regardless of my picture or whatever picture you've seen or will see, if you have a line that's tangent to the circle, it makes a 90-degree angle. N is also a point of tangency. So that is going to make a 90-degree angle. So points of tangency are 90 degrees. So I know that this is 90 degrees, and I also know that this is 90 degrees. So if I'm trying to find the measure of X, I have a 4-sided shape. So they're all going to add together to give me 360 degrees. So X plus 90 plus 117 plus 90. If I add all 4 of those up, it should give me 360 degrees. So X plus 90 plus 117 plus 90. Since I have a 4-sided shape, I got some sort of quadrilateral, I can add all that together and it's going to add to 360. So you would add all this together, subtract from 360, you should get 63 degrees. So I didn't go through that solving part. That should be something we know how to do. Add all these up, subtract that number from 360. We find that X is 63 degrees. So that's the answer for the first one. All right, problem number 2. All right. ED is tangent to circle O. Again, that is circle O. ED is tangent to circle O. Find the value of X. So let's zoom in on my picture here. it tells us that ED is tangent to my circle. So that means right here, if it's tangent to my circle, we have a 90-degree angle at D. So this is 90 degrees. I know that because this is my point of tangency. Point D is my point of tangency. So I have a triangle. So I'm looking for, I got D, E, and F. So this makes a triangle. So X plus 90 plus 38. If I add up these three things here, it's going to give me 180 degrees because 180 degrees is what the sum of the angles in the triangle add to. So we just do X plus 90 plus 38. And we set that equal to 180 degrees. So once you figure out what your point of tangency is, figure out what shape that you're working with. And that's how you know how many degrees to set it equal to, whether it's 360 or 180, whatever the shape is. So we add 90 plus 38, subtract from 180. Feel free to type that in any sort of calculator. You should get 52 degrees. 52 degrees. All right, number 3. Zoom out a little bit here. All right, number 3. BA is tangent to circle C. Circle C. BA is tangent to circle C at point A. Find the value of X. So here's another one again. We got another point of tangency. And they told us what the point of tangency was. It's point A. So that means this point right here is tangent to my circle, and it makes a 90-degree angle. So that is 90 degrees. So figure out what shape we're working with. It looks like a triangle here. So triangle ACB. So we can do 90 plus X plus 22. And we can set that equal to 180 degrees because that's how many degrees are in a triangle. 90 plus 22, subtract that number from 180. You should get 68 degrees. So points of tangency make a 90-degree angle from our radius to the point that it intersects at. So wherever that intersection happens from that point to a radius in the circle, then it's going to be 90 degrees. Okay, we're going to do another one. This one a little more involved, but we still can work our way through. Let's make sure we can see the whole problem here, and then I'll zoom in on the figure in just a little bit, just to make it a little bigger for us. All right, so it says a dirt bike chain fits tightly around 2 gears. The chain and gears form a figure like the one below. Find the distance between the centers of the gears. So we're trying to find the distance from this point here and this point here. All right, let's make this be a shape that we are a little more comfortable working with, because right now we don't have everything we need. So let's make this be something that we're a little more comfortable working with. So let me zoom in. So we got the gears on a bike. So I'm going to draw in a parallel line so that I have shapes that we are used to work with, like rectangles and triangles. So I'm going to draw in a parallel line from the little one over here to this big one. So I'm going to try my best to make it straight. And I've got a little bit crooked there. So I'm trying to draw in a parallel line. So I want my line to be 26.5 up here, and I drew in trying to make it parallel, going at the same slant as this one up there. So now I have a rectangle. So that's what I was doing up there. I now have a rectangle. So if I know that this whole section is 9.3, if I'm trying to find, and I know that this section here is 2.4, I can subtract to find my missing section. So let's do that again. I know that this is 2.4, and I know that this is 2.4. The whole thing is 9.3. So if I'm trying to find my missing number, I know that my missing number, I can just subtract. So I'm going to subtract over here to the side. So I'm going to do 9.3 minus 2.4. Hopefully you're writing in pencil, but you know how I do it in my videos so that you can see the numbers a little better than the pencil. So 9.3 minus 6.4 is what we're doing. So 9.3 minus 2.4, and that gives me 6.9. So this little section here is 2.4. this section here is 2.4. If I want to find the distance that's remaining, this little section here, I can just do the whole distance minus that. So I got 6.9. So how is that going to help me? Because now I have a right triangle that I'm going to draw in. So let me turn my paper so I can draw my right triangle in. Okay. So now we can do Pythagorean Theorem to find the missing length. So I'm trying to find the distance from here to here. So from here to here is the distance that we're trying to find. So now I can use the Pythagorean Theorem to help us out. So I'm going to write that over on this side so I have a little bit of space. So I now can do 26.5 squared plus 6.9 squared. So I'm doing a squared plus b squared equals c squared. So I now have a right triangle where I can go in and I can find my hypotenuse. So I'm now looking for the hypotenuse. So I know that this side is 6.9, this little section here, 6.9. And I know if this is 26.5, then I also know that this part right here is also 26.5. So this right here is my right angle. That's my right angle that I have right here. I know that one leg is 26.5 and my other leg is 6.9. Since I have my two legs, I'm able to find my hypotenuse, which is this part from the center here to the center here, which is what we're looking for. So we can plug this in any kind of calculator, the leg length squared. So that is going to give me 749.86. And then you got to take the square root. So my total is 27.38 inches. So by all means, let me recap this problem because I was scribbling out some things along the way. So let me recap this problem. I started out with just two circles. I had a little circle and I had a big circle. I split this problem into two shapes that we're comfortable working with. So I drew in the dotted line. I drew that in so that I now had a rectangle and now I had a right triangle. So if this side is 26.5, I know that this side is 26.5. If this side is 2.4, I know that this little section here where my pen is also 2.4. We found the 6.9 by subtracting 9.3 minus 2.4. Now we have a right triangle. To find the hypotenuse of a right triangle, you do Pythagorean Theorem. So we did a squared plus b squared equals my hypotenuse, which is what we're looking for, the distance between the two gears. So we got 27.38. Now, so that was my first theorem. So the first theorem says tangent lines to a circle. So there's also another theorem that we can use based off of tangent lines to a circle. So that's this top part up here. If a line in the plane of a circle is perpendicular to a radius at its endpoint on the circle, then the line is tangent to the circle. So here, line AB is tangent to circle O. So I have a picture here. So this is just kind of the reverse of what the first theorem says. So if a line in the plane of a circle is perpendicular to a radius at its given endpoints, then the line is tangent to the circle. So let's see this played out in action. So number 5, it's asking us, is ML tangent to circle N at L? And we have to explain ourselves. So I have this picture over here. So we're trying to figure out if ML, this line right here, if ML is indeed tangent to my circle. So we're going to use Pythagorean Theorem to test that out. So Pythagorean Theorem, a squared plus b squared equals c squared. So we're going to plug in my legs. And when you're doing Pythagorean Theorem, the longest side should always be c. So that's how I'm going to know that 7 and 24 are the legs, and this is my hypotenuse. So 7 squared plus 24 squared. And I'm going to put a question mark, and then I'm going to put 25 squared. So again, 25 had to go in your spot for C because that's the biggest side. So we're trying to figure out if 7 squared plus 24 squared does equal 25. So I put a question mark there because we're not sure of that yet. If you go through and do the math, I got 625 on that side and 625 on that side. They are definitely equal to each other. So we'll say yes. And our explanation would be that we went through and we did the Pythagorean Theorem, and a squared plus b squared does indeed equal c squared. Okay, let's try another one, number 6. Is ML tangent to circle N at L? And these are the lengths that they're giving us. They give us 4, they give us 7, they give us 8. You could draw a picture, but you also should know that 8 has to go in the spot for your C. So when I set up Pythagorean Theorem, 4 squared plus 7 squared, I'm going to put a question mark, and I'm going to put 8 squared. So 8 has to go in spot for our Pythagorean Theorem because that's where that's the biggest number. So I go through, I do the math, 4 squared plus 7 squared, that's going to give me, I got 65 on this side. And 8 times 8, I got 64. These two numbers are not equal to each other. So that means no. So in this case for number 6, ML is not tangent to circle N because I didn't get congruency on both sides. So we have an example where it works out, and then we have an example where it does not work. So we went through and we did Pythagorean Theorem. Last little mini theorem that we got for today, and then we'll try a couple examples with it. Here you go. So the two segments tangent to a circle from a point outside the circle are congruent. So the two segments tangent to a circle from a point outside of the circle are congruent. So AB is congruent. This is our congruency theorem symbol. AB is congruent to CB. So here's AB and here's CB. This theorem is telling us that these two line segments are congruent to each other. So the two segments tangent to a circle from a point outside of the circle. B is the point outside of the circle. And I have two line segments that are tangent to the circle. So by definition, I know that those two line segments should be congruent to each other. So let's go through and try a couple of examples, and then you'll be all straight for today. Let's read the whole directions, and then I'll zoom in a little bit there. Circle O is inscribed, meaning inside, triangle ABC. We want to find the perimeter of triangle ABC. So again, circle O in this picture down here is inscribed, meaning inside of triangle ABC. We want to find the perimeter, which is the distance on the outside. We want to find the perimeter of triangle ABC. So let me zoom in. So we're going to use the theorem that you just wrote down to help us figure it out. It says if I have a point outside of the circle, like point A, like point B, like point C, if I have a point outside of the circle and line segments that are tangent to the circle, then those points, those line segments are congruent to one another. So here we go. We know that we're given that AD is 10. So if AD is 10, A is my point outside of the triangle, AF must also be 10. So I'm going to put 10. So I had a point outside, that was point A. AD is congruent to AF because they're both coming from this point outside of the circle, which is point A. Let's do the other side. This is point B. BD and BE are congruent to each other. So this side is 15. All right, we keep making our way around the circle. This is point C outside of the circle. So CF is congruent to CE. So CE is also 8. Now, the problem asks us to find the perimeter. So you just add all these up. 15 plus 10 plus 10 plus 8 plus 8. We add all of this up. Use any kind of calculating tool if you want to. You got 66 centimeters. So if you have two line segments tangent to a circle from a point outside of the circle, they are congruent. So AD and AF are congruent. CF and CE are congruent. And BD and BE are congruent. Last one, we're going to go through and we'll do another inscribed angle circle here. This time we have circle O is inscribed in triangle PQR. Triangle PQR has a perimeter of 88 and we want to find QR. So let me go through and highlight my points outside of the circle. P is on the outside, Q is the outside, and R is the outside. Tangent C's, I got a point at Y. I got a point at X, and I got a point at Z. So we're going to make our way around and label what we know. So I'm going to start with P. PX is 15. So PZ must also be 15 because they're two line segments from an outside point. So that means that they are congruent. So I know that that's 15. Let's do it again. I got point R outside the circle. This is 17. RZ is 17. So RY must also be 17. I do not know enough information about QY and QX, and I'm actually trying to find QY. So let's set up what we know. We know the perimeter is 88. So that's our goal. We know that 15 plus 15 plus 17 plus 17 plus X plus X, okay? I do not know what these two values are, but I do know that they are the same. So QY and QX are congruent to each other. So I know that they are the same. So we'll go through, we'll add this up. 15 plus 17 plus 17 plus 15 gives me 64. And I got two X's. Subtract 64 from both sides, I got 24. And divide by 2, I got 12. So X is 12. It says find QY. So QY is 12. And then I know that the other part is also 12. So the answer to this problem is 12. So 3 things that we did today. The first thing we learned points of tangency. So points of tangency make a 90-degree angle when they intersect the circle. So you can set that up and find your missing degree. We also can figure out if 3 numbers make a right triangle by setting it up and doing Pythagorean Theorem and seeing if it works out. And then the last part that we just did down here with these 2 problems, we took a look at 2 segments tangent to a circle from a point outside of the circle.